Hi everyone. In this video, we're going to discuss solving equations by using opposite actions. Now, if you've watched the other videos in this series, we've explored a number of different ways to solve equations. Now, some of these ways don't seem very efficient. And one of the beauties in mathematics is finding efficient and simple ways to solve problems. So this video is going to introduce you to a simple way to solve equations. You've probably already realized that addition and subtraction are opposite actions in mathematics. Now, an opposite action is also called an inverse operation. If we think about starting with x, let's say I add 6 and I get an answer of 10. If I want to find out what x is, I do the opposite action, and the opposite of adding 6 will be subtracting 6. And 10 minus 6 gives me 4. Let's look at another one. If I start with x and subtract 3 and get 20, the opposite action of subtracting 3 will be adding 3. And 20 plus 3 is 23, which means x must be 23. I could write the equations as follows. X plus 6 is equal to 10. And the way I solved the equation was subtracting 6 from 10. Or in the second example, x minus 3 is 20. And the way I solved the equation was adding 3 to 20. Other opposite actions that you may know of are multiplication and division. Let's look at some examples of these. If I start with x and I multiply it by 8, get an answer of 24. If I want to find out what x is, I can do the opposite action, dividing by 8, and 24 divided by 8 gives me 3. So x is 3. And an example of division, if I start with x and divide by 5 and guess 11, the way to find out x is doing the opposite action, multiplying by 5, and 11 times 5 gives me that x is 55. If I want to write out the equations for these, I'm saying 8 times x, and the way we write that is 8x is equal to 24. Or x divided by 5 is 11, and the way we write that for algebra is x divided by 5 as a fraction is equal to 11. Let's look at solving some equations. Now in this video, I'm going to solve equations using arrow diagrams as my tool. In the next video, I'm going to show you how to solve equations working purely algebraically. So let's start with these examples. Firstly, I'll need to draw an arrow diagram. If I look at the equation, what happens first to the x? X is first multiplied by 3. And then the answer to that, we subtract 18 from that, and I end up with 15. So if I want to work backwards, I'm going to say 15 plus 18 gives me 15 plus 18 gives me 33. And then the opposite of multiplying by 3 is going to be dividing by 3. And so x will be 11. Let's look at the next one. Now, can you see it looks very similar, but some things are happening in a different order. If I start with y, what is the first operation on y? It is going to be minus 18. And then the next operation on y is multiplied by 3. So on the answer of y minus 18, that is multiplied by 3, and I get 15. Let's work backwards. 15, opposite of times, is divided by 3. And 15 divided by 3 gives me 5. And 5, opposite of subtracting 18, I'm going to add 18. And 5 plus 18 gives me that x is equal to 23. Let's look at some more examples. In this one, there's a lot going on. What is happening to a first? First, a is being multiplied by 2. Then I'm adding 1 to that answer. Then I'm dividing that answer by 7, and I get an answer of -9. So let's work in the opposite direction. The opposite of dividing by 7 is multiplying by 7, and -9 times 7 is -63. Then the opposite of adding 1 will be subtracting 1, and -63 minus 1 is -64. And then lastly, the opposite of multiplying by 2 is dividing by 2. And when I divide -64 by 2, I get that A is equal to -32. Next question. It looks similar to the previous question, but can you see things are being done in a different order? So I'm starting with B. First, B is being multiplied by 2. But what's different in this question is then the answer is being divided by 7. And finally, I'm adding 1. And I get an answer of -9. Now, if I work backwards, the opposite of adding 1 is minusing 1. So -9 minus 1 is -10. And then the opposite of dividing by 7 is multiplying by 7. So 10 times 7 is 70, and it will be -70. And then my final action, I will be dividing by 2. And -70 divided by 2 gives me that B is equal to -35. In these two examples, I already have the arrow diagrams drawn. But the extra challenge I have here is that I need to write out the equation I solved. So let's first solve the equation. Let's start on the right. 10 minus 7 gives me 3. And the opposite of multiplying by 6 is dividing by 6. So 3 divided by 6 is going to give me a half. So I get x is equal to 1/2. If I want to write out the equation, x times 6 will be 6x, and then I add 7, and I get an answer of 10. In the next question, let's work from the 7, and I'm going to do the opposite action. Now here, the opposite action is not the negative, it's actually dividing. So the opposite action will be multiplying by -3. So 7 times by -3 gives me -21. And then 21 will have to add 4. So -21 plus 4 ends me with -17. So my answer is x is equal to -17. I can check that. -17 minus 4 is -21. -21 divided by -3 and negative divided by negative gives me +7. And my equation is x minus 4. And now I'm dividing everything by -3. So let's put that all over -3 and I get 7. I'm sure you've noticed that despite me explaining these very slowly, that using this method to solve equations can actually be really quick. And when we move on to the next video, you'll notice that it's not necessary to draw the arrow diagrams. But for now, try some equations with arrow diagrams and see how much it helps you to solve that equation.